Welcome to solverfy.
Okay, so in this problem, we have to find out the empirical and the molecular formula of each of the following substances given here. So here are three substances given in A, B, and C. So before starting solving the problem, let's look at the steps we will follow to solve these problems. So the step one is we will consider the percentage of each element given in each substance as mass in gram. And then we will determine the number of moles of each element using the formula where number of moles is equal to mass over molar mass. So first we will consider the percentage of each element as mass, and then we will put this mass over the molar mass of this element to find the number of moles of that element. Then we will divide each number of moles by the smallest number of moles we have, and to get the simplest whole number ratio of the moles. And then in step 4, from the simplest whole number ratio, we will determine the empirical formula of the substance. And then we will determine the empirical formula weight of the substance. And then to find out the molecular formula, we will have to find the value of an n, where n is the molar mass or molecular weight of the substance over its empirical formula weight. And then finally, in step 7, we will determine the molecular formula from the value of n. Now let's go to our first problem. So in the first problem, we start with the step 1, where we have considered each percentage of the elements present as their mass in gram. So that means 75.69% is 79.69 gram of carbon. Then we have considered 8.82% hydrogen as 8.82 per gram of hydrogen. And as usual, for oxygen, 15.51% as 15.51 gram. Then in the second step, we have found out the number of moles of each element by putting their mass over their molar mass. So here we have the number of moles for carbon, the same way we have the number of moles of hydrogen, and here we have the number of moles of oxygen. And then from here we can see that the smallest value here is 0.97, and as we said that in next step we will divide each number of moles by the smallest number to get a whole number ratio. So here comes our so here we actually dividing each number of moles by the smallest number of moles, which is 0.97. So we divide the number of moles of carbon, which is 6.3, by 0.97. Then the number of moles of hydrogen, which is 8.73, we divide that by 0.97. And then finally, since 0.97 is the number of moles of oxygen, so we divide 0.97 by 0.97 and we get these values. Now here you can see that 9 and 1 are whole number, but 6.5 is not a whole number. So to convert it to a whole number, we will look for the smallest multiple which can make a whole number of it. So if we multiply 6.5 by 2, it will give us 13. So that is a whole number. But in that case, we will have to multiply each of the rest of the hydrogen and oxygen to have a balance between the number of moles. So we'll multiply 9 by 2 to get 18, and then we'll multiply 1 by 2 to get 2. So that means our Ratio now is the ratio of the number of moles now is 13, 18, and 2. Now from here we will find out our empirical formula, and here you can see that this is our empirical formula. Since we had 13 for carbon, we had 18 for oxygen and 2 for 18 for hydrogen and 2 for oxygen. That means the empirical formula of this substance is C13H18O2. Now from this empirical formula, to find out the molecular formula, we will put this N outside a, round bracket around this empirical formula, and where this N is the molar mass or the molecular weight of the substance over its empirical formula weight. And here n is also a whole number multiple, so if we find a fractional value we'll have to convert that to the nearest whole number. Now let's find the value of n. So before finding out the formula of n, let's find out, we'll have to find out the empirical formula weight of the substance. So from the empirical formula we can see that we have 13 carbon and the carbons. So the empirical formula weight is simply the sum of the molar mass, or um, so the sum of the molar mass of each element or atom present here. So first we have carbon, and carbon's molar mass is 12.01 gram per mole, and we have 13 carbon. That means we just multiply 13 by this molar mass of carbon. Then we have hydrogen, which molar mass is 1.008, and we have 18 hydrogen. That's why we multiply it by 18. Then we have 2 oxygen, and the oxygen's molar mass is 16. So we just multiply 2 by 16, and then we just add all these 3 up to get the empirical formula weight of this substance, which is 206.27 gram per mole. Now, now we know the formula weight of the substance, and we are given the molar mass of the substance, which is um, 206 gram per mole. We are given this value, and we have calculated the empirical formula weight as 206.27. Now if we divide this molar mass by the empirical formula weight, we get a value of 0.99, which is very close to 1, and we can consider the value of n as 1. That means now we will find out the um, now we'll find out the molecular formula, and that simply we will just replace the value of n here, and since the value of n is 1, that means the molecular formula is apparently same as the empirical formula for this substance. Now we move to our next problem. So in part B, again similarly, we first convert the percentage to mass in grams. Just we so in case of in this case we have carbon, hydrogen, and nitrogen, and we have converted all the percentages just simply to grams. We just considered the whole mass as 100 gram, and that's why this 58.55% is now 58.55 gram, and same for hydrogen and nitrogen. Now we will find out the number of moles of each substance, each element. So here um, the same way, we just divide each mass by their molar mass to get the number of moles. Here is the number of moles of carbon, then here is the number of moles of hydrogen, and there is the number of moles of nitrogen. Now again, we will divide all this number of moles by the smallest one, and here we can see the smallest number of moles is 1.96, which is the number of moles of nitrogen. We'll divide each number of moles by this 1.96, and it will give us values like this. So here you can see that um, for carbon we get a value of 2.5, for hydrogen we get a value of 7, and for nitrogen it's 1. So again here our hydrogen and nitrogen has whole numbers, But in case of carbon, we can see that we have 2.5. So if we want to have a whole number out of it, we just multiply this by the smallest possible multiple to get the smallest possible whole number. So if we multiply this by 2, we will get 5, which is the smallest possible whole number out of this. So in that case, we will have to multiply each of the rest by 2 to have a balance. So 7 times 2 will be 14, and 1 times 2 will be 2. So in this case, the ratio of carbon, hydrogen, and nitrogen will be 5 is to 14 is to 2. That means the empirical formula here will be C5H14N2. Since we had 5 for carbon, we had 14 for hydrogen, and we had 2 for nitrogen. Now we have to find out the molecular formula out of it. So again, similarly, we just put a bracket, and then we put an N as a subscript, and here N is the molar mass over the empirical formula weight. So now we'll find the so we are given the molar mass or the molecular weight, and now we have to find out the empirical formula weight. So empirical for the empirical formula weight, we simply um, what we do is we simply add the molar mass of each of the elements times the number of atoms of those elements present. So we have 5 carbons, we multiply the molar mass of carbon by 5, and then we have 14 hydrogen, we multiply hydrogen's molar mass by 14, and we have 2 nitrogen, so we multiply nitrogen's molar mass by 2, and the sum will give us this 102.2 gram per mole. So this is the uh, empirical formula weight of this substance. Now we'll divide the molar mass of the substance by its empirical formula mass, and here again we can see that the value of N is 1. That means the molecular formula of this substance will be also same as its empirical formula. Since the value of N, that means the molecular formula will be same as the empirical formula. So this is the molecular formula of this substance. Now I move to our part C of the problem. Again, we just first we convert each of the mass from percentage to gram, and then we will find their molar mass, find their number of moles by just dividing those masses by their molar masses. So we have carbon, hydrogen, oxygen, and nitrogen. And if we divide each mass by their molar masses, we will get number of moles like this. And then we will divide all by the smallest number of moles. Here we can see that the smallest number of moles is 0.55. Then we will divide each number of moles here by the smallest one to get the whole number ratio. So here is so here we have divided each number of moles by 0.55, and here you can see that we have got 8.93, which is very close to 9. So we'll consider it as 9. And then for hydrogen we got 12.8, which is also close to 13. We'll um, consider this as 13. Then for oxygen we got 2.98, and then since it's close to 3, we'll consider it 3. And for nitrogen, since it's 0.55 over 0.55, it will be 1. That means our empirical formula will be C9H13O3N. And then again, the molecular formula will be a bracket and then a N over the bracket. And here again, the N is the molar mass over, or the molecular weight over the empirical formula weight. So now we will find out the empirical formula weight first. So just um, look at here that for the previous two cases, we wrote uh, the molar mass for each element, and the unit was gram per mole. But in this case it is atomic mass unit, because in this case we are not given molar mass, we are given the molecular weight. So molar mass and molecular weight are basically same thing, but the thing is that for the molecular weight or atomic weights, the unit is AMU, or atomic mass unit, and for molar masses it is gram per mole. So make sure that which value you are given, either if you are given molar mass, then you will have to write the for the elements you will have to write the molar mass of each element. And if you are given the molecular weight, in this case you will have to write the AMU. So the values will be same, the weight is same, just the unit is different for molar mass and molecular or atomic weight. So again, we have nine carbon here. We just multiply so carbon's atomic weight by 9. Then we have 13 hydrogen. We multiply hydrogen's atomic weight by 13. Then we have 3 oxygen. We multiply oxygen's atomic weight by 3. And then we have 1 nitrogen. And the total will give us 183.19 atomic mass unit, which is the empirical formula weight of this substance. Now we will divide um, the molecular weight of this substance, which is given as 180 AMU, by the empirical formula weight, which we have just calculated as this, and the value will give us 1 again. So that means in this case also, the molecular formula, um, so we'll just find out, just replacing the n by 1, we will get this, and that means in this case also the molecular formula is same as its empirical formula.